Today's lab is experiment 11, water hydration. In today's lab, there are actually two different sections. The first section is about hygroscopic property. A hygroscopic property is a physical property for some substances that they can absorb water from the environment. We're going to use calcium chloride as an example to observe the hygroscopic property. Okay? The second part is to figure out the number of water in the substance. There are many substances inside their structure. They can combine a fixed part, a few water molecules in their structure. These kind of substances, we call them hydrate. Today, we're going to use experiment to decide how many water molecules will be in the hydrate of copper 2 sulfate. Now let's get the first part of the experiment started. Okay, the first part is the observation of the hygroscopic property of calcium chloride. So I'm going to take out some anhydrous calcium chloride. Anhydrous means without water. So I'm going to take out some of this sample out, put it on the watch glass. Your job is to write down your observation. Okay, how does the sample look like? The color, the physical appearance. You write them down, record them down on your report sheet. Then we will leave it alone on the side. We will move on to our second part of the experiment to decide the water in copper 2 sulfate. Then by the end of the experiment, we're going to come back to look at our calcium chloride sample again to see what will happen to the sample, whether there's any changes in the physical appearance. And that should be the result of absorbing water. Okay? By the end of the experiment, we're going to come back, look at the sample again, and you will record your observation again then. And in the report sheet, you should also include your conclusion or explanation of your observation. Okay, so I'm gonna take some sample out. Okay, so white powder. Okay, when I shake it, I don't know if you can see it, when I shake it, the white powder can flow freely. So the initial state of this calcium chloride sample, it looks like there are white powders that can flow freely. Okay, we'll leave it here. We're going to talk about the second part of the experiment. So the second part of the experiment talks about determination of the number of water molecules in the hydrate. And this is how we're going to do it. We're going to apply heat. We're going to take some of the sample out, copper 2 sulfate hydrate. Take some sample, we're going to heat it to drive off the water. So when all the water is gone from the sample, we are left with copper sulfate without water. We call it anhydrous. So we're going to heat hydrate to get anhydrous sample. Okay, so after this, what do we do? How can we decide that? Remember, this is the conversion we have been using in our lecture, and we use it in our experiment number 7. Okay? Again, we're going to focus on this part. Remember, given the grams of something, the mass of something, we can get the moles of that thing. This is what I'm going to use. So this is how we're going to do this experiment. We're going to measure the mass of the hydrogen sample. We take out, measure the mass of the hydrogen. Once the mass is known, remember we know the moles of the hydrogen. Then we will heat the sample, get the anhydrous. By the end of the experiment, we're going to measure the mass of anhydrous. Then we are going to subtract the mass of anhydrous out. Take out the mass of anhydrous from the hydrate. Mass of this one minus the mass of that will equal the mass of water. So this is the water inside the original sample before. Once you know the mass of water, you know the moles of water inside. Now you know the molar ratio between water and copper 2 sulfate. You decided the N in the formula. Okay, so that's basically the back-end chemistry inside this lab. Now let's start with experiment. Now this is what we need for today's experiment. A crucible tongs, an evaporating dish, a wash glass, a glass rod, some distilled water, and a sample of copper 2 sulfate hydrate. Now let's measure the hydrate sample. First, let's measure the mass of the evaporating dish. You need to write down this mass on your report sheet. The mass of the evaporating dish is 37,875 grams. 37,875. Please take a record of it. Now we're going to pour some sample into the dish. We're going to add somewhere around 4 grams. Okay. Take a look at the state of sample blue crystals. All right, please take a record of this mass again. Now the mass of the evaporating dish with the sample is 41.741 grams. 41.741 grams. Now we're going to place the sample on the hot plate. We're going to use the glass rod to spread out the sample a little bit to make the sample a thin layer so that the water can be driven off relatively easier. Okay, then I'm going to cover it with the wash glass, and I'm going to start heating. Now all we need to do is to wait. Now, how long should we wait? Well, how do we know if we need to stop the experiment when the water will be all driven off? Well, theoretically, what you should do, and this is what the lab suggests you to do, you should heat it. When you believe the water is all gone, you're going to measure the mass of your sample on the dish. Okay, take a record, then heat it again, measure the mass again. You keep doing this until the mass measurement will no longer change. Okay, if the mass doesn't change anymore, that means regardless how much you want to heat, water is all gone. So that's what we're supposed to do. We'll keep heating the sample and keep measuring the mass repeatedly until the two last mass measurements stay close enough. And the lab manual tells you how close they should be so that you can stop the experiment. Well, in addition to that, there's another indication that can tell us, okay, our sample might have been dried enough. Water might have been all gone. That is by observing the color of the sample. Remember, the sample we put into the evaporating dish originally has a blue color. They're blue colored crystal. When the water is all gone, the anhydrous copper 2 sulfate should be a pale white color. The pure one should be white colored, solid. Okay, but there might be some impurities in the sample, so the sample may show some kind of gray-white color. So let's take a look of our sample right now, okay, to see how it looks like. All right, the color has become gray-whitish. There's no blue color inside the sample. So it should be dry now. Let's take a measurement of the mass. Now let's measure the mass of the sample in the evaporating dish. The mass measurement is 40.364 grams. 40.364. You want to record this on your report sheet, line number 4. Now I move it back, cover it, heat it for another 10 minutes. Let's take the mass measurement again to see if the water is gone completely. For days, 0.320, 40 grams, 40.320 grams. Please take a record on your report sheet, line number 5. Well, let's check the two measurements, 4 and 5. 4 is 40.364. 5 is 40.320. The difference is 0.044. Good. It is less than the 0.05 required by the experiment. So we're done. We're done for the measurement. By this time, we have had all the data we need for this experiment. All the other numbers on your report sheet are actually calculations based on this measurement. Please make sure when you do these calculations, make sure you follow the operational rules for measurements. All right, so one more thing we need to do for this part of the experiment is that we want to add some water back to the anhydrous sample to see what will happen to it. I'm gonna take some water. I'm gonna point it to the sample. All right, so I'm gonna drop in water. Watch carefully to see what happened because you need to record this down on your report sheet. It's line number 13, I think. So watch carefully. Oh, it is sizzling and the color. Okay. goes back to blue. Okay, that's what happens. The anhydrous copper 2 sulfate, when it absorbs water, it goes back to copper 2 sulfate hydrate. That's why the color becomes blue again. We have one last thing to do before wrapping up the experiment. Remember, at the beginning of the lab, we put some calcium chloride sample, white powder, on a watch glass. We looked at its appearance. We said it was white powder that can flow freely. Now let's take a look at the sample again to see if there's any change. This is the sample. It cannot flow anymore. I can barely call it powder. They got stuck onto the glass and they cannot move at all. And if you watch closely, you might be able to observe some water droplets around it. Okay? You need to record all these observations. Whatever you see the state or the appearance of the sample right now, you need to record it down. To me, they got stuck together, they cannot flow anymore, and we see water droplets around the sample. Okay? Now, those are not pure water droplets. You see water droplets there. That's because some of the calcium chloride there absorbed so much water that it forms a solution. That's it for today. Okay, you need to make sure record all the data, do the right calculation, and finish your report sheet. Okay. See you next time.